It's another episode of Maker Monday. Thanks for joining us. And if you've been watching our channel, you will know that last time we had an introduction to facial recognition software that we are going to put together.
I hope you guys all did the homework.
I hope you did some research and homework, because Noor gets very angry when you don't do your homework.
Come on, I'm a good guy.
He's not a good guy. No, he is a good guy, and he's going to explain to us what the next step is. So the last episode, we spoke about the concept of what we're doing, the steps that we need to do, and now we're going to start doing the steps. And the first thing is data gathering.
So what I did basically was simple, just took my 40 pictures, 20 with this and 20 with this, and just to show the true example and the bad example. And once you get these data, import it into your drive or
How many do you need,
Mac
by the
or
way?
whatever.
Like how many?
You need, the more it is, the better it is. The different the background, the better it is.
Okay, background should be different.
Yeah, and these different portrait or
Angles
the other one,
and whatever.
angles, better it is.
Okay.
So whatever you have to disturb the entropy of the system, it is better.
Okay.
But just for the simple example so that everyone can follow through, I just took the picture, the same angle, the same background, 20 pictures
So you just run around
true
taking selfies.
samples and 20 pictures with bad sample. That is the bad sample
All right,
for me.
and that's what we're going to be using for this.
Exactly. And now if you capture this photo from this phone, it's really in megabytes, and I don't want this photo to be in megabytes. I want to have a really simple picture. So what I did was to simply open these pictures and then using preview and then change the size and just turn the pixel into as small as you can.
Okay.
I
So really low quality then.
I convert it into 120 by 160. It's not a good practice. For better result, you have to have a better features, better high definition, better resolution, so that your machine goes into it and finds the data. So, and the naming why I used was that we will see how it benefits us in the future. Okay. So I just named image true for true images and image false for the false images, and just kept it like that. So out of these 40 images, what we did, kept 18 true images and 18 false images here, and had some test images which we will need in future.
Okay.
So we made two folders called train and test.
Okay.
All these just remove, test and train.
Okay.
And train will have all the data set and just pick some of them out of it and just put it in the test, or take the new ones and put it in the test.
Okay, what is the test for? The test is to test it later, I assume.
Exactly. So once your algorithm is trained, we will try to predict that if it picks up the right thing.
Okay.
And if it picks up the right thing, it means that our algorithm is working better. So this is exactly how you will do for the bigger real-time example.
Okay.
All right. So that is all from the preparing your test data.
Okay.
Or the train data. So always remember these two keywords: train, on which we will be training, the tests, on which we'll test. That's
Okay.
simple.
Got it.
So after that, you will have to install the Anaconda or thing. But people who are using Linux or thing, just you can obviously can directly install Jupyter as well. But if you have Anaconda, it's better. All you have to do is write Jupyter notebook, and it will open up a URL for you, and that's your Jupyter notebook on your browser.
Okay.
And what this is we are doing because we are training this model on our PC right now. But for the real-time examples, the real-time data, the Amazon has big blasting notebooks available on the market.
Okay.
Google has the same kind of frameworks, and they are really much supporting right now this whole new thing. So if you are uninterested to work on your machine and spend some time here, you can buy something on the cloud and pay as you go and use it there.
Okay, interesting.
So that's the second option. And so all you get is this Jupyter interface, and all you have to do is right here. So as you can see, my images here and the train which we showed in the Finder. And let's just jump into the code. All right. So
let's do it.
I created my own notebook, and we will see step by step what are we doing and what is it to for. All right. The first part would be to gather all these images and convert it into a pixel vector.
Okay.
And what is a pixel vector is that your image, which is 120 by 120, it's converted into a string of 120 square strings in a single dimension.
Okay.
So what we'll do, we'll fetch every image and we'll convert it into an array of simple image pixel vector.
Okay.
So I have the two arrays, xtrain true, xtrain false. We will see how we just use it. And then we have the ytrain. What does ytrain does? Ytrain does simply that initialize an array for 18 units because we have 36 images.
Okay.
18 will be true and 18 will be false.
All right.
1 and 0.
So it knows exactly how many to expect.
Yeah. And after that, we fetched up all the array in such a way that, hey, get all my train array. If the image has a file name true, append it into a true array.
Okay.
And if it's false, then append it to a false array.
All right.
This is why I say that, hey, just put it in the image right now, so that we can align all the images in a single array.
Yeah. And that's also, I think, with bigger projects where the time comes in, because it's actually the data preparation of making sure that you're naming all of the data correctly, that it's labeled correctly, and in some cases you might have metadata and so on. So it's
exactly.
all...
So once you have the array, you see we just convert it into, we can use the RGB over here if you want. And was one parameter that's you can use. And then we flatten the image into a single dimension, and then we combine. First array is the true and the second array is false. This actually coincides the 36 elements of the ytrain, which have 18 elements true and 18 elements false.
Okay.
So 36 elements in ytrain, 36 elements in xtrain, and 36 true false.
Okay.
All right. Then we move forward and we prepare our y-test. Y-test had 10 elements. We initialize the same thing, 5 for y-test, and this is the same for our image array.
Mm-hmm.
Nothing else. Go into the test, append the test true, append in the test false. These are two arrays.
All right.
And then combine them together to make the 10 elements of the images. Now comes a most interesting part. So these learning algorithms are in this term called classifiers, which classifies these different techniques. Apply different techniques on different data. Now, you cannot learn in any book in a simple way that, hey, this classifier works good for this classifier works. There are some which can give you exact answer that, from my experience, this classifier works really good on this kind of data set. So what kind of data set you have? You have an audio, sometimes you have the audio set, sometimes you have a real-time video, sometimes you have just single images, or natural language, or document analysis, different parts of different things. And these classifiers always have their own unique characteristic and it's something that you always gather from the experience if you're working on it. So this is just for this example, we will be using different kind of classifiers, and we will see that how just from the top, that how a little bit of tweaks can make a change.
Okay.
Right? So our first classifier is the decision tree classifier.
Okay.
So all the classical programmers know what is a decision tree is. It's a binary yes, no, yes, no. This is exactly what decision tree is. It picks up a question. For example, we take lemons and oranges. We'll say round. When we say round, lemon oranges came into one category. But when we say red, the lemon and orange separates.
Okay.
And this is how the basic decision tree works.
Okay.
But we discussed it in our last video that there can be overfitting and underfitting.
Yeah.
And this is the problem of the decision tree.
So how where it comes in.
Exactly. The more decision tree you train into a data, the more fit your data, your model gets, and it cannot recognize any other thing apart from apples and lemons.
Okay. or underfitting and overfitting.
Exactly. So for that, we will see our, as mentioned here, we have our score. And this score will tell you that how good this classifier worked on our tool. And should we use it, should we not? Should we tweak a little bit or just completely switch it over?
Okay. So you're going to talk us through that, right?
Exactly.
What's happening in your decision tree?
Yep. So our images were simple. And I eliminated most of the part which is called feature extraction. Feature extraction is one of the major advantage you can give to your learner. We're not going into that depth.
No.
Right now. We will go in future maybe, but let's see. So what do we have?
For now, no.
Yeah.
Keep it simple.
Exactly. So we initialized an object from the decision tree and this random state kept it 2. Just keep the random state 25 right now. We will discuss that later on.
Come back to 25 random state.
Yeah, but let's execute these steps. We haven't executed it. Shift, 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 shift. And yeah. So we initialize an object and then there is this keyword called fit.
All right.
And fit, X-train and Y-train. What was the Y-train? True and false, true and false. And X-train was what is a good example and a bad example.
Right.
Now, what a fit does is fit tries to make the sense that why the true was true and why the false was false.
Okay.
And this is a black box. This is the black box that you. I don't want the developers who are using it to go into deep right now.
Yeah.
Just know that it converges all the things together.
Because this is where the whole thing about machine learning comes in, where you can lose track of what's actually happening inside the system.
Exactly. Yeah. And there are mathematicians who are building it. Yeah. And if you want to use it, just use it. And this is why I'm doing this, just using it.
Yeah.
But knowing a little bit in the depth actually empowers you to know exactly what classifier to. And this is the reason why there are so many long courses of in the Coursera by Andrew Ng and everything, that they give you an intuitive sense of what classifier to pick.
Okay.
So we have this fit thing, and what it does, it converges this X-train into Y-train and makes the sense of the data.
Okay.
And once it makes the sense of the data, we will say, hey, good. Now can you predict our test and tell us
is this good or not?
How much good are you?
Yeah.
So what it does, what we said, hey, DTC means the decision tree classifier. Yeah. Can you please predict the X test for us? What was the X test? X test was the examples we kept for the testing.
Yeah.
And after that, we say, can you give us a score? And then we match the score from the Y test.
Okay. Because all right. To see how well
let's see, print our score and let's see.
Yeah.
It give us the 50% result.
50% result.
So every time I put an image and say, hey, you tell me, is this me? It will say 50%.
I'm 50% sure.
Of course, because 50% was in my head.
Yeah.
And the images were more similar.
Okay.
And so that was a decision tree classifier, and now we jump into the logistic regression. This is a second type of...
the old logistic regression.
No, the old logistic regression. So... logistic regression is another tool which we can use. So what we did, hey, logistic regression, we initialized the logistic regression. We then again tried to fit as we did with the decision tree, and then we had some score.
Okay.
We predicted it.
We can get a score out of this as well.
And when we print our score and it runs and it gives 0.6, a little bit better for our example.
Okay.
Now, this increment of the score not at all means that one algorithm is better. Maybe our data set was in such that this is working better right now.
Okay.
Are you getting my point? So maybe
somewhat.
Yeah. So it's not at all. This example is not showing that this algo is better than the other. It's not like that.
It's just showing that this process
for this data set
brings
this is working much better.
Different point.
All right.
Okay.
So you have to experience more to exactly know what things we have. So the next we have the Gaussian naive Bayes classifier.
Okay.
When you have unlimited data and you want to have a really high predictably true and false, you use the simple Gaussian naive Bayes.
Okay.
And we'll see the score. And I'm skipping the process in between because it's the same as the other. So we ran and the score
is
0.5.
0.5. Okay.
All right. So last we have the random forest classifier. Now, what is a forest? Forest is a bunch of the trees, and we have random forest, which is the bunch of decision trees. Now, imagine these decision trees being generated in many these decision trees, and then what random forest does is find an average out of this to combine all these values to give you
coming out of the decision trees, you mean?
Exactly. So we go into a random forest classifier, and we did the same thing. Hey, random forest classifier initialize, do this, and print our score. And it's 0.5. It means a 50% accuracy again.
Okay.
But there are a few tricks and tweaks we can do. Hey, increase the random state to 25. The random state variable has a huge documentation, and if you check out the documentation, it has a huge impact on your model, on your results. So you can see the details in their documentation and see what it does and how it actually impacts on the initial state of your learner.
Okay.
All right, so I increased the random state 25, and you can see the result became 0.8.
Way better.
And it does not at all mean that increasing the state means increasing the probability of your result.
All right.
So if we increase it to, let's suppose, 100, it drops down back to 0.5. So it's when you have a data set and you want to play on the data set and find the results better and better.
Okay.
So it's you have to tweak here and tweak there, right classifier, right thing, and then you find a good result.
Okay, I see.
So it's a continuous process. I've shown the one example. You can build on top of it. And the last part was we don't want to train our data again.
No.
This time we had a small data. It was being trained like this. We are predicting like this. But in the real time, you have a really huge chunk of data, and then what will you do?
Yeah.
What you do is you take that trained model, you save it, and then you use that trained model to predict that for the next time.
Okay.
So there is just an example. We dumped all our random classifier into a Pickle. Pickle is the way to put your data into a file and just put it in Python's directory.
Okay.
And so I pickleized it. And once you want to see it, so you can see here, I initialize a random forest classifier. It loads a Pickle, and we just directly predict from it. So yeah, that's it. So the next part in the future videos, if we continue in this,
if we get taken off the air, we're done.
So what we will be doing is we'll be just using these Pickle, the dataset. First of all, we will improve our datasets so we can use it for the real time.
That can be part of the process, right?
Exactly.
Improving the dataset. So we'll actually see that in action, how you
and the classifiers and why we use some classifier and why not the others.
Yeah.
And the third part would be to integrate it onto a Raspberry Pi or maybe any of the other cameras available online, so that it sees you and then opens or give a signal that red light, green light. Should we let it go or not?
Right. And I guess a lot of this will make more sense as well when we see that next episode with the things in progress and how are you using them to improve the data set.
So when I followed the tutorial, I knew why I always getting picked up on the random checkings at the airports. So yeah.
What a pickle. Okay, so please join us for the next episode where we will talk more about these classifiers, about optimizing our data set, and also the whole reason we're doing this is to put it into an implementation. It'll be a really basic implementation, but we want to show how we can use these concepts in your smart home and your the things that you make.
All the DevOps, all the developers who are really afraid of this monster.
Yeah, and there's no need to be afraid.
Let's hunt this monster together. That's what
we're hunting the monster together. Yeah, with our pickles. We're going to bring it down. But yeah, thanks, Noor. That was very, very interesting.
Thank you very much.
And I look forward to the next episode. Thank you for watching. Subscribe to our channel as usual. We'll see you next time.